So welcome to this talk. I'm Michael Opdenacker. I'm the previous founder of Bootlin, and now I have my own company. I'm a contributor to Yocto. I never missed any ELC Europe since 2007, since the first one. I hope it continues this way. And I'm working as an expert and consultant, so working on Yocto-based projects, kernel-based projects, any embedded-related stuff. And I also have some courses too, like the Yocto Project and Open Embedded ones have free materials and like 3 days of practical lab time. So you could give it a try. The documentation is freely available. So an introduction. Why this presentation? The first thing that motivated me is that the Yocto manual for this part, like making images more secure, is a little shallow. It just gives you very quick ideas, but without diving into the details. So I think there are opportunities to improve it. So through this research, I have more information that could contribute into the manual. Oh, I don't see my timer anymore. Yeah, there it goes. I also happen to have a customer who has like a security audit in. I need to implement something as part of this project. So I'm glad to do this research as well from all the resources I found. So, and as usual, I'm happy to share what I'm learning. And so this is not like super advanced, but I did find ways of implementing some steps that make a device more secure. So that's what I wanted to share, like practical steps. And I'm going to focus on the Yocto specific ones, right? I won't be able to cover much wider topics like that are really meaningful, of course, like firewalls, encryption, using extended file attributes, and things like security modules in Linux, like Tomoyo, AppArmor, SMAC. Also, how to manage software updates, secure boot. All those things need to have their proper presentations, so that wouldn't fit in 40 minutes, and unless I transform myself into Steve Rosted. So getting started. There's the modern approach to security. So you may know this show, like Mr. Garrison. In my presentation, he's the president of a device making company, and he claims our products are 100% safe. And Mr. Hat, head of information security, says, well, actually, we found some vulnerabilities in our products. Our team is preparing fixes. And then Mr. Garrison gets red. You're fired. Our products are 100% safe. President Garrison is always right. If you know the show, you know what I mean. So that's probably too easy. I mean, you're not looking for this kind of shortcut. So let's take a more traditional approach to making the device more secure using science. Science is something some people should try. So the first thing you could try is to, of course, use a long-term support Yocto release. There's one every 2 years, so that's great. I mean, you get updates, vulnerability updates, all those things for 4 years, and you have like 2 years to switch between the previous LTS release and the next one. You should also choose your kernel carefully. So an LTS kernel is from kernel.org is probably the best option to get kernel updates very quickly, like in matters of days. I mean, they have a nice process and they're much faster than we are. Linux Yocto is also pretty well supported by the Yocto project, but sometimes it takes a few weeks, like to propagate the upstream changes to Linux Yocto, but it's still reliable, and that comes from thanks to the funding from project members that we have this guarantee. And then you have vendor kernels. This will support your hardware well, but that's not really meant to include vulnerability fixes in a timely fashion. They mainly are meant to support the hardware. So it's really a hard job to follow. So their job is to make the hardware work. So that's not the best solution. Something you should do too is create your own distribution. Don't start with Pocky. People have to. Everyone should repeat that. Pocky is made for testing purposes, like really test what the Yocto project releases, and then it has way too many unnecessary features, right? So that increases, of course, the attack surface. And actually, it's not a problem to start from scratch. So in this distro, just create this distro.conf file, just this one, and it inherits the default settings, and you are ready to go. And at this stage, it's also good to start having two types of images, like that share lots of things, of course, but they have the same base, but they have settings for development and for developers, and other settings for production. And this way, you don't have like a production a development setting that you forget to remove when you go and prepare the production images. So it's really nicer here to have two images that share some settings, but they have unique settings that are specific for development, like being read-write, being like no root password and things like that for the development image. And for the production image, you have some hardening settings, so that's much easier. And the risk, yes, is less risk of forgetting debug features in the production image. And by the way, if you're curious, I'm not using Canva. I'm using Excalibur.io. For those people who know me, I like to avoid proprietary software. It's a very nice open source software that runs in your browser, and it creates those fancy diagrams. It's really nice. Give it a try. I had a quick look at Meta security layer, and it's maintained by Scott and Marta. I had like kind of wrong expectations about it. I thought I could use it, and it would allow automatically, if I use the security setting, add some more compiler flags to secure my my build. But it's actually not exactly that. It's a set of tools that really help with hardening your system, like TPM, like integrity, all the stuff you want to use for securing your device. But it doesn't really help with the regular OE core stuff like Meta OE. It's for its own features. And if you look at the security distro feature, it's mostly adds fragments to the kernel, like to enable SMAC, AppArmor, DMVerity, EcryptFS, LKRG. So it's really kernel specific. So it doesn't. It's useful, but it's not like the silver bullet for security. It's like a repository containing useful elements for security. Let's talk about system hardening. And of course, a good idea is to reduce the attack surface. So in recent versions, it's good to know, like in VulnScout, they removed debug tweaks, which was a really risky image feature, which contained like empty root password, root login, empty root login, it's empty root password and allow empty password. So it's like too risky, and it just was looking not so harmful with debug tweaks, but it is. So it no longer exists. If you want to have those features, you need to add them explicitly to your features. So that's what I'm suggesting here. Only in the development image, you can use allow empty password, empty root password, and I have a few ones like that contain development tools or testing tools. Like Tools SDK will contain an SDK that will run on the device, and definitely it's not something you want to have on the production device, because an attacker could create their own programs if they had this. So here I'm showing that's something you put in the image dev BB, right? The recipe for image dev. So I'm giving the files that are modifying where I put the settings that I show. You could disable some distro features as well. If you look at distro features, for example, you have Bluetooth support, you have USB host, zeroconf, NFS that you might not need in production, so remove them, right? Just using distro features remove, that works. And you check what's remaining. Oh, everything is recorded anyway, so I'm going quickly through the slides, but I have many of them. So you could also remove unnecessary packages. So the first thing to do is check what packages you get. And I first tried to use bitbake getvar image install, but that doesn't really completely work because you have package groups that intervene in the way the images are defined. So if you really want to see what's in an image, it's best to check the manifest files that are generated by Yocto. Next to the image files, there's a manifest file, and that lists all the packages that went into the image. So to remove unnecessary packages, you can't really use image install remove because yes, some things are part of package groups. So I'm using package exclude, which is really the good way to do that. So you just select what you want to remove, provided it doesn't break dependencies. You can remove lots of things this way if they were brought in by a package group. Another thing is to harden the password security. First thing is using stronger passwords. Take the time to read this one, I love it. Yeah, that's a strong password. Little stronger than the usual ones. So I was looking at how to make device-specific credentials. So you can create passwords and users with Yocto, but the thing is they apply to the image you make and they apply to all devices, so that's not so nice. I mean, if one device is compromised, all the devices will be compromised. So I explored a solution to create, to set the credentials at first boot, at least the root password. Another thing you could do is to expire the credentials in the image you create, and therefore as soon as somebody logs in, they will be forced to change the password. That's what happens here. Like there's password -e when you create the password, and then if you try to log in, it says your password has expired. Please choose a new password. But as long as you haven't logged in, the old password the original password is still in use, and yeah, that's vulnerable, right? So the first one that comes in gets a chance to change the password. So I found a way to set the root password at first boot, at least for the systems that are based on systemd. You can actually create a new service, a new unit that's actually one of the prerequisites of the getTTY service. So before starting the login prompt, you actually run this check that, if it's the first time, will reset the root password and will ask you to input a new one. So that's how I did it. You have to compile systemd with the first boot option. So that's one of the components of systemd. And you create a configuration file that specifies this service, like how it's going to run systemd first boot. And that looks like removing the root entry from etc password, etc shadow actually. And then you can change the root password, and then you create a file that says done, first boot done. So and it's tested every time. I use it as a precondition, but if you do that as a precondition for this unit, then the whole service getTTY doesn't get run at all. So that's why I had to repeat the test in all the lines that I was running. And then to deploy this file, just create a recipe that installs this configuration file, the service unit, and that's about it. That's pretty easy to do. So that asks for. I thought I had a screenshot, but that asks for a password right away to set a root password. And that's one solution that could work in some cases. Of course, it may not be applicable to all devices, of course. Let's talk about user space hardening too. Let me check the time. Yeah, so you have nice compiler hardening features in OE core, securityflags.inc and Rust securityflags.inc that you can include in your distribution. So that's what I'm doing here in the production one. And it seems at least all of OE core and Meta OE compile fine with that. So that's like GCC options for maybe for address space randomizations and things like that, like things that make it harder to break into an existing program. So there's no cost in adding those to your programs. Of course, you may reduce the debuggability, but you still have the development image for that purpose. So that just goes to the production image. And at this point, we really want to test the user space and look for mistakes like bad permissions. And if you listen to security talks, Linux is quite secure, but what happens is like the biggest source of vulnerabilities is poorly configured services like NFS, which has too many writes, so like poorly configured services that have to open, they're not locked down enough. So that's the thing you want to check, right? So at this stage, it's good to add yet another image. It's the production test image. That's mostly the production image plus some tools. But for those, because we're going to run some tools on the device that will check for potential things that should be hardened. But you don't want to run that on the development image because you would get false positives because of the development tools. So that you won't actually run them on the set of tools that are on the production image. So that's why I'm introducing here yet another production test image that can make sense, right, to have these tools run in something that looks like the production image. So I looked for user space hardening checkers. If you look at the ones in meta security, it's quite disappointing because like there's bug security, but it's like 10 years old and it's based on Perl, so I'm not really excited to contribute to it. There's check security, which still works, but the example don't work as documented. It's only maintained by Debian, not very actively. There's a web scanner as well, Nitco. So that's the time when I could need some of your input.
Linus is quite good, and also in meta security. LYNIS.
Why? Oh yeah, that's the one that you told me. Thanks. LYNIS, right? And there's OpenSCAP. That anybody using it? Or who's using tools for this purpose to check your root file systems? Yeah? Yeah.
I use the OpenSCAP a bit.
Okay, the command is OpenSCAP is used as well. So nice to check out those tools. So OpenSCAP is supported by Meta Security, indeed. Another thing you should do too is run public services with limited resources. And light HTTPD, for example, from OECore is run as root by default, which is lovely. So, you know, a web server running a root, that's a bit ugly. So, yeah, of course, if the web server is compromised, the whole system is compromised, so that's really a terrible misconfiguration. So, yeah, you should restrict the privileges and resources from this. So, it's actually, if you're using systemd, it's actually very easy to fix. So there's a proof of concept here fixing it. I'm actually modifying the service file that comes with the sources of light HTTPD. So that's a systemd service file. So I just tweaked this to start it to start the service with a specific user, light HTTPD, and a group daemon which already exists on the system. And you can also tweak the capabilities that are granted to the server. So I'm using what they advertise, like cap bind a net bind service, which allows to have like ports below 1024, but all the other things are denied. So it just needs this. There's another issue though, is that a log HTTPD will want to write to /var/log, and it belongs to root by default. So there's a permission issue. So here. What I did to overcome this is to, as a setting, since varlog is actually in tempfs, it's in RAM. That's how systemd manages it. The good way to fix that is to change the permissions of varlog directly before starting the service. So that's the bit ugly part, because I mean it could conflict with other parts of the system. So that's not trivial here to just submit that to OECore. So I will actually submit an RFC for people to, let me know what could a clean solution to this be without interfering with other services. So yeah, because of writing logs, you need to manage the permissions globally on your system, and not only on that specific package. Yes, Peter?
So it's better to actually create a subdirectory with the right permissions.
Oh yes, that wouldn't interfere. Yeah, yeah, and I can change that in the configuration file for. Yeah, good idea. So change the default. That's a good point. Yep. That's more likely to get accepted. So then you start the server as intended. You reboot the system, for example, to see, and it does start as a normal user process, and it seems to work from the requests I made. But again, I haven't checked like with access to certificates and things like that. So there may be other trouble that I haven't found. But at least this proof of concept works. And so to make it work, I'm showing you what I did. So I just created in my own layer a baby append for Light HTTPD that adds this service file that was modified to run as a user, and a BB append that just that creates the user. Super easy with Yocto, as you can see, with OE, and adds the special file, overwriting the one that's provided by that's copied by the default recipe. So yeah, systemd seems like a good option for security, in my opinion, because it can really run some services and applications in a more restricted environment, like with exactly the right the sufficient privileges, and also with limited access to system resources. Like, you don't need to access the whole file system. You just need to access a set of files or a very specific part of the file system. Some namespaces like what processes you see, and we need to see, and all those things, plus an amount of RAM, an amount of CPU, an amount of I/O, whether you have access to the network or not. So of course, don't try to implement it by yourself. Systemd is here. So that's in my opinion, it's a good solution. Let's talk about kernel and bootloader hardening as well. And I won't spend too much time, but I found a kernel hardening checker from Alex Popov. Sorry. So Alex Popov, one well-known kernel contributor on the security side. It was introduced in OE core, in Meta OE, sorry, in VulnScout, and it reports all the kernel configurations and command line settings which you could change to harden the running kernel. So it's biased a little bit. It may not be exactly compatible, suitable for everything that your system is doing, but it does work, and it gives you good ideas at least, so that things you should review. So yeah, it will show all the configuration settings you could change and all the command line options you could change. And so that's a Python script, not Perl. That's nice. And so I sent an update last week to Meta OE to support the latest version, which really adds a lot of features. Like, we moved from 0.610 to 0.610.2, but it's not a bug fix release. Believe me, it's like a massive a set of changes. Supporting RIS5, by the way. And so I also submitted a backport to ScarfGap for people who are on the LTS side. So just add it to your image. And it lists all the kconfig settings and ultimately all the command line settings that you could change. You can have a look. So, and you can also run this on your PC. Just check out the Git repository from Alex Popov and run it. Nothing else to do. So if you want to improve your distro kernel as well, your PC kernel, you can use it as well. Some hardening notes, by the way, still about the kernel. It's important to remove unnecessary features because that could be part of an attack surface. So remove unnecessary drivers. That tool won't find that. And what helps is actually Yocto stores the kernel modules in separate packages. So you have a long list of packages, and you can see, do I need that? And then you can remove those. If you want to know more about the kernel protection schemes, tools, you can have a look at security self-protection in the kernel kernel documentation. Most techniques to harden the kernel are explained in that, like kernel address space randomization and all those interesting things. For bootloader hardening, something that's important is make sure your bootloader is well maintained. So if you can use your boot mainline, it's great. that you will have the best updates from this. Implement, of course, secure boot and verified boot if possible. I checked at U-boot and didn't find any guidelines for increasing the security, or very, very, very little. So it's a few things you can do, except for removing unnecessary features like USB, like SD card or networking, whatever, TFTP. Something I didn't know was that it's possible to say config delay, like the delay for the countdown, to a negative value, and this really disables the any chance to get a U-boot console. If you just use 0, if you're fast enough, you can still interrupt the countdown. So -2 is better. And another safe thing you can use is auto boot encryption. That will ask you for a key, a passcode, to unlock the shell. You might want to try that as well. Some other hardening techniques. Read-only file system is good stuff too, because well, it helps to. It's one of the elements that make your system more secure. So you can use. It's pretty easy with Yocto. You can, without changing too much, you can just use add read-only rootfs to your file system, to your image, and just make sure that your read-write partitions, because you will have read-write partitions anyway, are created at root file system creation time. Because if you used systemd before, you'll find out that systemd automatically creates the mount points for the partitions. That doesn't happen, of course, if the file system is read-only. So I just had to do that, like as a post func for do rootfs. You can create your mount points in your image. So I also had to use OverlayFS etc from Slava. He's here, right? Slava, where are you? Oh yeah, thanks. Because my scripts to make a unique root password are actually modifying etc. So I needed etc, that part of etc at least to be read-write, right? So, but except for this need, I was surprised that systemd wasn't bothered at all. If you boot it on a read-only file system, it just boots fine, because all the modifiable files like etcresult.conf are links to actually some var tempfs, so some volatile file system that sits in RAM. So everything works fine. So it's nice discovery, and therefore I didn't have any need for the OverlayFS class, at least in my case, unless you have, of course, applications that want to store stuff in the root file system and it's hard to change. So yeah, it's been 3 years since this exists, and it was about time to try this. So thanks, Lava. So here's what I just had to do to support OverlayFS in my system. You just add OverlayFS etc to your image features, and then specify what's the read-write partition, what's the mount point of it, what its device, and what's its file system type, and that's about it. And I just had to add OverlayFS support to my kernel. That was missing in the BeaglePlay one, BeagleBone Yocto one. It was missing that configuration, so that's super easy to do with Linux Yocto. Just add a CFG file with the right setting. Piece of cake. And now to maintain your system. Now it's running. You should address vulnerabilities, of course, keeping an eye on them. So, of course, well, the way security checking works is that you connect to a database and you compare the known to be vulnerable versions with the ones you have deployed, and that's how you can know whether some packages on your system are vulnerable. So to do that, you just have to inherit the cvcheck class from a configuration file, and of course you don't want you also want to avoid false positives or CVs that have been recognized by the Yocto community as irrelevant in our case. So we have like a set of exclusions here that's good to include to your distribution. Something relatively new too is if you want to make, as you are going to make queries to the NVD database, you can ask for a key. So you just look at the documentation. You can get a key from NVD, and that key makes your requests faster because they know you are a trusted source. So big bake your regular image. The checks will be run, and or you just can run the checks on a specific package to save time if you want, like with chv check. And then how to exploit the vulnerabilities. So the way I was doing that until recently was just grabbing unpatched in the CV summary.json file, like showing the number of unpatched vulnerabilities. But now, since last week, there's VulnScout from Savoir-Faire Linux, like a nice company in France and Quebec. They have at last have a tool to consume the Yocto SPDX output and also the CV report from Yocto and update the vulnerability report without needing to run Yocto at all. So at last we have something to consume the XPDX and something we can give to our customers, and our customers just need to run that tool, a tool like that, to assess their vulnerability status according to the latest vulnerabilities. So that's really nice. I've been waiting for this for years now, and so I was really excited. And when I saw that they were making progress, I worked with them like to test and make sure to test what they were cooking and make sure that everything was ready for this week. So that's super recent, but it's great because it supports 2.3, SPDX 2.3. It means all Yocto releases, SPDX 3.0, like the recent ones, plus also CycloneDX. And it also takes into account the initial vulnerability report from Yocto. So how to use it? You can use it directly if you want, but they also ship a Meta VulnScout layer from the same people that supports ScarfGap, so that's the LTS, Opdenacker, and Mainletter, so the latest releases. So you just inherit VulnScout in your image, and it takes care of generating the YAML file that you would otherwise have to write by hand. So it's nice because it does the right thing, and it even gives you the command to run to start VulnScout. So, well, here's how you should run it. If you have made a run before, you should remove the existing container. That's not documented yet. And then it's just about running Docker on a YAML file and starting the Docker container. And then you have a .vulnscout directory that you can use, that you can reuse in the future and run it like without Yocto. Like you run the same command again, and what you get is an update. So I ran it this morning. So it shows the initial CV report I got from Yocto like a few days ago. It hasn't discovered any new CVE, but in the future, like in the next days, probably there will be a new CVE, so that the graph will change. So you can that's a web-based tool. You can browse all the vulnerabilities by type, severity, status. You can even make some edits. I don't know exactly how this works, but you could add your own notes, and maybe it's severity notes to this. I guess it's for your own consumption. There's also Patch Finder, like it tells you if you move to the next, like another version of Linux Yocto that will reduce the number of vulnerabilities by -10, things like that. So it's quite nice. So please try and interact with the people at Savoir-Faire Linux. They do a great job, and I mean that's a huge service to the community, in my opinion. And then, of course, you can need to address vulnerabilities in your products. So the idea basically is to get whatever, if the Yocto community is not giving you one yet, please try to contribute to fixing some issues, like looking at upstream, looking at the distributions too, and help us generating a patch to fix the known vulnerabilities. That's how, I mean, we are a community above all. There's some funding from members to take care of that, but it still relies on volunteers like us to accelerate the process. So yeah, that's an example here, like a patch and it's well documented in the Yocto manual how to how to do that. You could also mark some vulnerabilities as irrelevant in your case. So, and that's you just have add a CV status flag in the recipe to say this one is irrelevant in our case. You can even group CVs of the same type that address the same problem. I mean, that are fixed by, or they have the same exception. Okay, almost done. So key takeaways here from this. Of course, it's best to use LTS versions of Yocto and the kernel. You need 3 images, at least in my opinion, a development one, a production one, and a production test one. And so remove unnecessary packages and features, no shared passwords, find a way. Also, switch to read-only file systems. You could even use SquashFS or HeroFS, which are really read-only, so they have a guarantee that it's not possible to modify them. I also advise to use systemd to restrict the privileges of applications. Like, take the time to review the privileges and resources that are used to start some services and applications. Give a try to kernel hardening checker again on your PC and on your embedded platform. It's available now. And yeah, there's as I said, a scarf gap patch in MetaOE, the MetaOE mailing list. And look for tools. Try the tools for checking user space for potential issues. And if you, of course, that's one part of the job. Of course, all the other parts I've mentioned, like secure boot, TPM, firewalls, have to be considered as well. And there's, at last, a new tool called VulnScout that allows to do your vulnerability assessments without having to need Yocto. So you can ship it to your customer, and the customer can do their own verifications without needing the build system, which is great. I think, in my opinion, that was the whole point of XPDX. So at last, we have something like that. So you are going to be busy. Some resources. So all my files are available in a small meta security demo layer that I have on GitLab. I have the author, Esa, who made really great blog posts about various aspects of Yocto hardening. Like, you say it's 9, but you have actually more than 9. the ones that are not listed on the main page. And Esa is also making Sulka secure Yocto distribution, which is a good example. I mean, you could find interesting things on it, and you could contribute to it as well. And if you guys are interested in security, by the way, my favorite podcast about security is called Darknet Diaries. It's really fun. It's not hyper technical, but it relates very fun stories from people who have hacked into some systems, like from the evil guys' perspective normally, and sometimes like good guys too, the blue teams and red teams. And so it's really a very nice podcast and very entertaining. And the next one is going to be about DEF CON, all the fancy people, the fancy creatures you meet in those conferences, not like these ones, but. And so the guy is called Jack Resider, and he actually wears a mask, so nobody knows his real face, actually. So here's where you can find the presentation. You can reach me on Signal, on XMPP. It's decentralized. It's even better than Signal. LaTeX sources are here. And yeah, you can also use them for your own presentations. So this leaves about normally between 2 and 3 minutes for questions. Please. Oh, could someone take a picture so that I can post about this talk? A picture of me, and you send it to me through LinkedIn, for example. Any questions? Any comments? Any things you? Yeah, please.
On the U-boot console disabling part.
Yeah.
I think it's a good practice, but especially if you have secure boot enabled, that's usually a little bit insufficient, because
Right. Oh yeah.
you can just set, and then you get U-boot console. You can
Yeah, Ahmad was saying that something like that. Yeah. If
there's I'm from Toradex. So
yeah.
we have the patch series for U-boot hardening, some of which is on its way upstream, some of which is a little bit too specific.
Is that on Meta Toradex security?
It's mostly Toradex security.
Ah. I'm lucky because my project is with you guys, like Toradex.
If you're worried about sort of U-boot's attack surface being a way to circumvent secure boot, you need to go a little bit further. So we do things like having a command whitelist and blacklist
Yeah.
for U-boot that prevents you from, if you get either U-boot console access, or importantly, and a lot of people forget this, you have boot script injection via the software update system. Whatever software update
Oh, yeah.
you're using, you have to inject something in the boot script, right? So you need a little bit more. You want to. There are some things you can't fully disable. There are some commands you have to harden. There are some commands you have to blacklist. It's in the layer.
Yeah. Oh, okay, I'll have a look. So there was a great talk from Ahmad before, like right before. So Ahmad Tatum, check it. It was a nice talk about hardening the bootloaders, and it was talking about those things too. Anything else? Yes, cool.
So one of your examples was setting a package config for a recipe in your distro file.
Yeah, for systemd.
That's a real good way for it to silently fail. If you want hardening, use a versioned VDFN because if upstream changes, it will error out instead of.
Ah, okay. Okay. Thanks. Anybody else? Yes, Kevin?
I have some customers. They're on an older version of Yocto. So what happens then? Because in terms of hardening and security,
Which versions of Yocto?
some are even on code
Okay, yeah.
or stuff, yeah. For them to move, right, forward takes a while,
Right.
realistically speaking. So then what needs to be done? Is it going to be a problem?
Well, what I'm showing is not so should be used. I mean, Kirkstone. I'm not sure it has OverlayFS. Probably it does. Yeah. So yeah, it's what they should avoid, of course, is being stuck with something that's not supported anymore. So that's. I hope this presentation helps to convince to move to newer versions that are better supported. And the most important thing is not those features, but like the security features that are regularly published for the LTS releases.
It's probably more important to like get them on a path to where they are
Right.
able to have the OS underneath them, be moving forward, and they can have their value add application stack and security and everything float above that and not matter. And that requires automation, but it's a lot of training and hand-holding, and it's really hard to get management to get it.
So we're out of time. Thank you for your presentation, for your participation and listening and comments. Thanks.